Far beyond the blue skies of Earth lies a mysterious world, Mars, a planet that has fascinated humankind for centuries. But beneath its red surface hide stories untold. For generations, we've looked up at this crimson dot in the night sky, wondering what secrets it holds. Today, we're not just looking. We're going there. Join us as we journey to the red planet to uncover its past, understand its present, and glimpse into its future. This is the story of Mars, a world on the brink of awakening. So why Mars? What is it about this dusty, cold planet that captures our imagination so intensely? For starters, it's our closest planetary neighbor, a world that in many ways is a sibling to our own. It has a day that's almost the same length as ours, polar ice caps, and seasons that change throughout its year. But the similarities don't stop there. Billions of years ago, Mars was a very different place. Evidence from rovers like Curiosity and Perseverance tells a stunning story, a story of a warmer, wetter world. Imagine standing on the surface of ancient Mars. Instead of the rusty desert we see today, you'd be looking at vast lakes, winding rivers, and perhaps even a shallow northern ocean. The sky would be thicker, the air more substantial. This was a Mars that might have had all the necessary ingredients for life. Liquid water, organic molecules, and a source of energy. It's this tantalizing possibility that drives our exploration. Did life ever arise on Mars? And if it did, could traces of it still be found hidden in the ancient riverbeds or beneath the surface? To find these answers, we've sent an army of robotic explorers. From the very first flybys in the 1960s to the rovers tirelessly trekking across its surface today. Each mission has built upon the last, painting a more and more detailed picture of our neighboring world. The Sojourner rover, the first wheeled vehicle on another planet, showed us it was possible. Spirit and Opportunity, the twin rovers, were true marathon runners, exploring for years and discovering definitive proof of past water. And now, Perseverance is on the hunt for a holy grail of planetary science. A sign of ancient life or biosignatures, Perseverance is not just a geologist. It's a pioneer. It's drilling into Martian rock, collecting the most promising samples and sealing them in tubes to be left on the surface. Why? For a future mission, a complex collaboration between NASA and the European Space Agency, to pick them up and bring them back to Earth. This is the Mars Sample Return Campaign. For the first time in history, we will hold a piece of another planet in our hands, ready to be studied in the most advanced labs on Earth. These samples could rewrite our understanding of the solar system and our place within it. But the exploration of Mars isn't just about looking at the past. It's also about preparing for the future. A future where humans might walk on its surface. Living on Mars presents enormous challenges. The thin atmosphere offers little protection from solar radiation. The temperatures can plunge to bone-chilling lows. And then there's the dust, fine as flour, that gets into everything. To overcome these hurdles, we need to be incredibly innovative. We need to learn how to live off the land, a concept known as in situ resource utilization. That's where missions like MOXIE come in. It's an experiment aboard the Perseverance rover that has successfully produced oxygen from the Martian atmosphere, which is mostly carbon dioxide. It's a small-scale demonstration, but it's a monumental proof of concept. Imagine future astronauts using this technology to produce breathable air and, critically, the oxygen needed for rocket propellant to return home. We're also experimenting with growing food in simulated Martian soil and developing habitats that can protect humans from the harsh environment. Every small step we take now is a giant leap towards a sustainable human presence on Mars. And let's not forget Ingenuity, the little helicopter that could. Initially planned for just a few test flights, this small drone has far exceeded all expectations, completing dozens of flights and becoming an essential scout for the Perseverance rover. It has given us a literal bird's-eye view of Mars, helping to navigate tricky terrain and identify interesting geological features from the air. Ingenuity has opened up a whole new dimension of planetary exploration. Future missions will undoubtedly include more advanced aerial scouts, capable of exploring canyons, caves, and volcanoes that are inaccessible to rovers. So, what does the future hold for Mars? In the coming decades, we can expect to see the first human footprints on its red soil. This won't be like the Apollo missions to the moon. This will be about establishing a foothold, a base, a home away from home. The first Martians won't be visitors. They'll be residents. They will be scientists, engineers, and explorers, laying the groundwork for a self-sustaining colony. It's a vision that might seem like science fiction, but it's a vision that the brightest minds on Earth are working to make a reality. The dream of Mars is a shared one. It pushes the boundaries of technology, inspires the next generation of explorers, and forces us to work together as a species. The challenges are immense, but our curiosity is even greater. Mars is more than just a destination. It's a mirror reflecting our own drive to explore, to understand, and to reach for the stars. From a distant, mysterious point of light to a world we are actively exploring and planning to inhabit, Mars is awakening. Alright, let's journey back in time. Not just a few thousand years, but billions. Imagine looking up at the Martian sky, not a red, dusty haze, but a familiar blue. Imagine a world with sprawling oceans, vast lakes, and meandering rivers carving their way through the landscape. This wasn't a science fiction dream. This was once the reality of Mars. For a long time, scientists have seen the clues, the telltale signs etched into the planet's surface. We've seen ancient river deltas, just like the ones on Earth where rivers meet the sea. We've seen vast, smooth basins that look uncannily like dried-up ocean floors. And we've seen winding channels that could only have been carved by flowing water. The evidence is overwhelming. Mars was once a water world, a blue marble in our solar system, second only to Earth. But as you look at Mars today, it's a cold, barren desert. A world of red dust and rock where the air is thin and freezing. The great oceans are gone. The rivers have run dry. So the billion-dollar question, the mystery that has captivated scientists for decades is, where did all that water go? How does a planet with enough water to potentially cover its entire surface in an ocean hundreds of meters deep become the desolate wasteland we see today? This is one of the greatest detective stories in the history of space exploration. To solve it, we need to understand what happened to Mars's atmosphere. Think of an atmosphere as a planet's protective blanket. Earth's thick atmosphere and our global magnetic field work together to keep our water safe. The atmosphere creates pressure, which allows water to exist as a liquid on the surface. The magnetic field, generated by our planet's molten core, acts like a shield, deflecting harmful solar wind streams of charged particles constantly blowing from the sun. This solar wind is relentless, and without a shield, it can literally strip a planet's atmosphere away, molecule by molecule. And that we believe is a huge part of the Martian story. Early in its life, Mars, like Earth, had a molten, rotating core. This generated a magnetic field, a global shield that protected its young, thick atmosphere. With that atmosphere in place, water could pool into lakes, flow in rivers, and form vast oceans. Mars was warm enough and had enough atmospheric pressure for a water cycle, much like our own. But Mars is smaller than Earth, only about half the size. A smaller planet cools down faster. As the core of Mars cooled and solidified, its dynamo sputtered and died. The global magnetic field vanished. Without its shield, Mars was left vulnerable. The sun's solar wind slammed into the planet's upper atmosphere, unchecked. Over millions and millions of years, this constant bombardment stripped away the air. It was a slow, methodical process, like a cosmic sandblaster eroding away the Martian sky. As the atmosphere thinned, the pressure dropped. Imagine trying to boil water on a high mountain. It boils at a lower temperature. On Mars, as the pressure plummeted, the boiling point of water dropped so low that the liquid water on the surface simply couldn't stay liquid anymore. A huge portion of the water on the surface would have essentially boiled away into the atmosphere, a process called sublimation, where it goes straight from a solid or liquid to a gas. Once it was water vapor in the upper atmosphere, it was exposed to the sun's intense ultraviolet radiation. This UV light is powerful enough to break water molecules H2O apart. The hydrogen, being the lightest element, was so light that it easily escaped Mars's weak gravity and floated off into space, lost forever. The heavier oxygen atoms likely reacted with the iron-rich rocks on the Martian surface. This process is called oxidation. It's the same process that causes iron to rust here on Earth. So, the very thing that gives Mars its distinctive red color is likely the ghost of its ancient oceans, the oxygen rusted into the soil. So one part of the mystery is solved. A significant amount of the water was lost to space. But that can't be the whole story. The sheer volume of water we think Mars once had is staggering. Could it all have just vanished into the cosmos? Recent missions like NASA's MAVEN orbiter have studied this atmospheric stripping process in detail, and while it's a major factor, the numbers suggest it doesn't account for everything. There had to be another place for the water to go. The answer, it seems, wasn't just up, but also down. Beneath the red dust, Mars holds more secrets. We're now discovering that a massive amount of its ancient water might still be there, locked away underground. Think of it like a planetary deep freeze. As the climate changed and the planet got colder, a lot of the remaining water seeped into the ground and froze, becoming permafrost. But it's more than just frozen soil. Scientists believe a substantial portion of this water became trapped within the molecular structure of minerals themselves. On Earth, we have hydrated minerals, rocks that have water molecules chemically bound within their crystal lattice. On Mars, this process could have locked away an ocean's worth of water into the crust itself. Rovers like Curiosity and Perseverance are our geologists on the ground, drilling into rocks and analyzing their composition. They've found abundant evidence of these hydrated minerals. So the story of Mars's lost water is a two-part tragedy. Some of it was blasted into space, atom by atom, after the planet's magnetic shield failed. But a vast reservoir, possibly 30 to 99% of its original water, didn't leave the planet at all. It's still there, chemically imprisoned within the rocks and frozen deep beneath the surface. This is a profound realization. Mars isn't just a dry husk. It's a planet that has sequestered its own water. This changes how we think about the potential for past or even present life. If water is still there, locked away underground, could pockets of it occasionally melt? Could there be briny, salty aquifers deep below the surface where microbial life could potentially survive? The search for Mars's water is not just about understanding its past climate. It's a fundamental part of our search for life beyond Earth. Every new piece of data, from orbital scans showing subterranean ice deposits to rover samples of hydrated clays, adds another chapter to this incredible story. The blue, vibrant Mars is gone, but its legacy is written in the rusty dust, the deep canyons, and the frozen, mineral-rich ground beneath our rover's wheels. The water is not entirely lost, just hidden. And as we continue to explore, we are slowly, piece by piece, uncovering the secrets of the drowned world and learning just how a planet can lose its oceans. This story isn't just about Mars. It's a cautionary tale that teaches us how precious and fragile a water-rich world, like our own, truly is. So the big question remains, are we alone? When we look to Mars, the evidence starts to get incredibly exciting. For decades, scientists have been debating the possibility of past or even present life on the red planet. And some of the clues are truly tantalizing. Let's start with something that fell right into our laps: meteorites. Not just any space rocks, but meteorites that we know came from Mars, blasted off its surface by ancient impacts and traveling through space for millions of years before landing here on Earth. One of the most famous is Allen Hills, 84,001, discovered in Antarctica. When scientists put this rock under a powerful electron microscope, they found something astonishing: tiny worm-like structures that looked remarkably similar to fossilized bacteria, what we call microfossils. Could these be the remains of ancient Martian microbes? The debate has been fierce. Some argue these shapes could be formed by non-biological geological processes. But the resemblance to early life forms on Earth is undeniable, and it opened up a thrilling new avenue of research. This discovery sent a shockwave through the scientific community and spurred a new era of Mars exploration. We had to go there and look for more direct evidence. This brings us to the hunt for organic molecules, the very building blocks of life as we know it. For a long time, we couldn't find any. But then NASA's rovers, like Curiosity, started drilling into Martian rocks, into layers of mudstone that formed at the bottom of an ancient lake billions of years ago. And there, protected from the harsh surface radiation, they found them. Complex organic molecules, the carbon-based compounds that are essential for life. Now, this isn't a smoking gun. These molecules can be created by non-living processes too. But finding them in a place that was once wet and habitable is a huge piece of the puzzle. It tells us that the necessary ingredients for life were present on early Mars. It's like finding a pantry stocked with flour, sugar, and eggs. It doesn't mean a cake was baked, but it sure means it could have been. And the story gets even stranger. While rovers like Curiosity and Perseverance are sniffing out the past, satellites orbiting Mars are detecting signs of something happening right now. They've detected plumes of methane gas burping into the Martian atmosphere. Here on Earth, The vast majority of methane is produced by living organisms, from microbes in the soil to cows. So finding methane on Mars is incredibly intriguing. What's more, this methane isn't spread evenly. It appears in specific locations and seems to vary with the seasons, spiking in the Martian summer. This could suggest that something is actively producing it. Could it be underground pockets of microbes, waking up as the ground thaws slightly? Or is it a purely geological process, like water reacting with rock deep beneath the surface? Scientists are still working to figure this out. The European Space Agency's Trace Gas Orbiter was specifically designed to map this methane and pinpoint its source. Solving the mystery of Martian methane could be one of the most important discoveries of our time. Let's put all these pieces together. We have potential fossils in Martian meteorites. We have the chemical building blocks of life preserved in ancient lake beds. And we have mysterious bursts of methane in the atmosphere today. None of these things on its own proves that life exists or ever existed on Mars, but when you look at them all together, they paint a compelling picture. They tell a story of a planet that was once warm, wet, and Earth-like. A planet that had all the necessary ingredients for life to emerge. And they hint at the possibility that deep beneath the cold, dry surface, some form of that life might be clinging on, a hidden biosphere waiting to be discovered. This is why we send rover after rover, each one more advanced than the last. We're not just exploring another world. We're searching for a second Genesis, a second example of life in the universe. The implications are profound. If we find definitive proof of even simple microbial life on Mars, it would change everything. It would mean that life isn't a unique fluke that happened only on Earth. It would suggest that the universe is teeming with life, that wherever the conditions are right, biology can take hold. This idea is what drives the explorers, the engineers, and the scientists who dedicate their lives to the Red Planet. They're searching for microscopic fossils in drill cores and analyzing atmospheric gases, all in the hope of answering that fundamental question. The search for life on Mars is more than just a scientific endeavor. It's a search for our own place in the cosmos. Every rock turned over, every sample analyzed, brings us one step closer to knowing if we are truly alone or if we have neighbors just one planet over. The next steps are even more ambitious. The Perseverance rover is currently collecting the most promising rock and soil samples and sealing them in special tubes. The plan is for a future mission, a collaboration between NASA and the European Space Agency, to launch a spacecraft to Mars, land near these samples, pick them up, and launch them back to Earth. For the first time, we'll be able to study pristine pieces of Mars in our most advanced laboratories here on the ground. Imagine what we could learn from those samples, analyzing them with equipment far too large and complex to send to another planet. This Mars sample return mission could be the one that finally gives us a definitive answer. It's an incredibly complex and challenging undertaking, but the potential reward is the greatest discovery in human history. The clues are all pointing in a fascinating direction. From the very first grainy images sent back by Mariner 4 in 1965, Mars has captivated us. It wasn't the lush, canal-covered world some had imagined, but something far more intriguing. A planet with a past. A world that might have once been like our own. This tantalizing possibility sparked a new age of discovery, a robotic invasion driven by human curiosity. Our first real emissaries to the Martian surface were the Viking landers in 1976. These weren't just cameras. They were sophisticated laboratories designed to answer the biggest question of all: is there life on Mars? They scooped up the rusty soil, analyzed its chemistry, and conducted experiments that, to this day, spark debate among scientists. The results were ambiguous, inconclusive. Mars wasn't giving up its secrets easily. But the Vikings gave us our first taste of the Martian environment. The thin, cold air, the pink sky, the desolate, rock-strewn plains. It was an alien world, yet hauntingly familiar. For 2 decades, a kind of Martian silence followed. Then, in 1997, a new kind of explorer arrived. It was small, no bigger than a microwave oven, and it was called Sojourner. Delivered by the Pathfinder lander, this little 6-wheeled rover was a game-changer. For the first time, we weren't just stuck in one spot. We could move, we could explore, we could wander among the rocks. Sojourner's journey, though short, proved that rovers could work on Mars, paving the way for a new generation of more ambitious explorers. The early 2000s saw the arrival of a dynamic duo, the Mars exploration rovers, Spirit and Opportunity. These twin geologists were sent to opposite sides of the planet with a clear mission: follow the water. They were built to last for just 90 days, but they shattered all expectations. Spirit roamed for over 6 years, climbing hills and uncovering evidence of ancient hot springs. But it was opportunity that became a legend. This relentless rover traversed the Martian plains for nearly 15 years, covering more than a marathon's distance. It found definitive proof that liquid water once flowed on Mars in the form of tiny iron-rich spheres nicknamed blueberries and layers of sulfate salts. Opportunity's long journey painted a picture of a planet that was once warmer, wetter, and potentially habitable. Then came the heavyweight champion. In 2012, the Mars Science Laboratory, better known as Curiosity, executed a daredevil landing sequence dubbed the 7 Minutes of Terror. This car-sized rover was a rolling chemical lab, equipped with a powerful laser to vaporize rocks and a drill to sample their interiors. Curiosity landed in Gale Crater, a massive impact basin with a towering mountain of layered sediment at its center. Its mission was to search for the chemical building blocks of life and assess whether Mars ever had the right environmental conditions to support microbes. And the answer was a resounding yes. Curiosity discovered an ancient stream with smooth, rounded pebbles, proving water once flowed vigorously here. It drilled into mudstone and found complex organic molecules, the carbon-based compounds that are fundamental to life as we know it. Curiosity confirmed that ancient Mars was not just wet, but had all the necessary ingredients for life. But the story doesn't end there. In 2021, the most advanced rover yet touched down in Jezero Crater. Its name, Perseverance. Jezero was chosen for a reason. Billions of years ago, it was a deep lake, fed by a flowing river that built a beautiful, fan-shaped delta. If life ever existed on Mars, this is one of the best places to look for its fossilized remains. Percy, as it's affectionately known, isn't just looking for past life, it's collecting the evidence. It's drilling core samples of the most promising rocks and sealing them in ultra-clean tubes. These samples are being carefully placed in a cache on the surface, awaiting a future mission to retrieve them and bring them back to Earth. For the first time, we will be able to study pristine pieces of another planet in our most advanced laboratories. And Percy didn't travel alone. It carried a stowaway, a small helicopter named Ingenuity. This tiny marvel was a technology demonstration, designed to see if powered, controlled flight was even possible in Mars's incredibly thin atmosphere. Its first flight was a Wright brothers moment for a new world. Ingenuity not only flew, but it exceeded all expectations, completing dozens of flights and acting as an aerial scout for the rover. It has given us a new perspective on Mars, a bird's-eye view of the canyons and dunes that Perseverance is exploring. From Viking's first scoop of soil to Perseverance's collection of pristine rock cores, our robotic explorers have transformed our understanding of Mars. They are our eyes, our hands, and our chemical sensors on a world millions of kilometers away. Each mission builds upon the last, asking more complex questions and venturing into more challenging terrain. They are more than just machines. They are the embodiment of our insatiable desire to explore, to understand our place in the cosmos, and to answer that profound, age-old question: are we alone? The story of Mars is still. Have you ever looked up at the night sky, spotted that faint red dot, and wondered, what if? What if humanity could have a second home? A backup plan? A new frontier? That red dot, Mars, might just be our best bet. But it's not exactly move-in ready. With its thin atmosphere, freezing temperatures, and barren landscape, it's one of the most hostile environments imaginable. So, how do we go from a desolate wasteland to a thriving new world? The answer sounds like something straight out of science fiction. We terraform it. Terraforming is the ultimate cosmic renovation project. It means literally, Earth shaping another planet to make it habitable for humans. The idea isn't new. Scientists and dreamers have been sketching out plans for decades. The goal is to warm Mars up, thicken its atmosphere, and eventually introduce liquid water. Imagine, for a moment, the Valles Marineris, a canyon system that dwarfs our Grand Canyon, filled with a flowing river. Picture the polar ice caps melting to form vast oceans and shallow seas under a pale pink sky. It's a breathtaking vision of a future where humanity is no longer confined to a single planet. The first step in this monumental task is warming the planet. Mars is cold, with an average temperature of about -80 degrees Fahrenheit. To raise the thermostat, we need to kickstart a greenhouse effect. One popular idea is to build giant orbital mirrors, massive satellites that would reflect sunlight onto the Martian poles. This concentrated solar energy would vaporize the frozen carbon dioxide trapped in the ice caps, releasing it into the atmosphere. As CO2 builds up, it traps heat, creating a positive feedback loop that warms the entire planet. Other, more aggressive proposals include building factories on the surface specifically designed to pump out powerful greenhouse gases. As Mars warms, the atmospheric pressure would increase. Right now, the air on Mars is so thin that your blood would boil without a spacesuit. But as more CO2 is released, the atmosphere would thicken. Eventually, it could reach a pressure high enough for liquid water to exist stably on the surface. This is the tipping point. With liquid water, life as we know it becomes a real possibility. We could start by introducing hardy microorganisms, like bacteria and lichens from Earth's most extreme environments. These tiny pioneers would begin the slow process of converting the Martian soil and atmosphere, producing oxygen as a byproduct. Over centuries or even millennia, these simple life forms could pave the way for more complex plants. Imagine the first forests taking root in the red soil, their leaves reaching for a sun that looks just a little smaller and dimmer than our own. These plants would accelerate oxygen production, gradually transforming the sky from its reddish hue to a familiar blue. With a breathable atmosphere, humans could one day walk on the surface of Mars without a helmet, feeling the wind on their faces and breathing in the air of a world we built. Of course, this vision isn't without its challenges. The scale is almost unimaginable, the costs astronomical, and the timeline stretches far beyond our own lifetimes. And there are huge ethical questions. Do we have the right to fundamentally change another world? What if there's already microbial life hidden beneath the surface? These are questions we must grapple with as we stand on the precipice of becoming a multiplanetary species. Visionaries like Elon Musk and organizations like SpaceX aren't just dreaming about it. They are actively building the technology to take us there. The rockets and starships being assembled today are the first tools for this grand endeavor. They envision domed cities at first, self-contained bubbles of Earth-like life that would act as staging grounds for the larger terraforming effort. These cities would be marvels of engineering, with recycled air and water, underground farms, and everything needed to sustain a new branch of human civilization. From these initial outposts, the work of transforming a planet would begin. It's a project that would require the cooperation of generations, a shared goal for all of humanity. It's a dream of turning the red planet green. A dream of not just visiting the stars, but making them our home. The journey is long and the challenges are immense, but the possibility of a second Earth is a powerful motivator. The first step now, we've arrived at perhaps the most exciting chapter of all: human colonies. This isn't just science fiction anymore. It's the next great leap for humanity. Imagine the first human pioneers stepping onto the red soil of Mars. They'll face a world utterly alien and hostile. The nights will be unimaginably cold, plummeting to temperatures that can freeze carbon dioxide straight out of the atmosphere. The air, or what little of it there is unbreathable. And with no magnetic field or thick atmosphere to protect them, they'll be exposed to a constant barrage of deadly cosmic radiation. The challenges are immense, almost overwhelming. But when has humanity ever shied away from a challenge? We are a species of pioneers, driven by an insatiable curiosity and the relentless desire to explore the unknown. Just like the first explorers who crossed vast oceans, the first Martian settlers will be defined by their courage, ingenuity, and unwavering spirit. They will not see obstacles. They will see opportunities to innovate. The first days and weeks will be a race against time. Astronauts in advanced spacesuits, our modern-day armor, will get to work immediately. Their first task, establishing a base camp, a small beacon of human presence on a new world. They'll deploy inflatable or 3D printed habitats, creating a pressurized sanctuary against the harsh Martian environment. These initial structures are more than just shelters. They are the first homes on another planet. Power will be the lifeblood of the new colony. Vast arrays of solar panels will be unfurled across the Martian landscape, soaking up the faint sunlight to energize life support systems, scientific instruments, and construction equipment. These shimmering fields of technology will be the first sign of a self-sustaining outpost, a testament to our ability to harness even the weakest stellar energy. Next comes the challenge of survival. How do you feed a colony millions of miles from Earth? The answer lies in Martian agriculture. Greenhouses, carefully sealed and climate-controlled, will be erected. Inside, under the glow of specialized LED lights, the first extraterrestrial crops will be grown. Scientists will use hydroponics and aeroponics, growing plants in nutrient-rich mist rather than soil, to maximize efficiency and conserve precious water. The sight of green leaves sprouting on Mars will be a powerful symbol of life's tenacity. Getting around on this new world will require a new kind of vehicle. Advanced, pressurized rovers will become the primary mode of transportation. These mobile laboratories will allow astronauts to explore farther than ever before, venturing out to conduct geological surveys, search for water ice, and scout locations for future expansion. They are the covered wagons of the 21st century, carrying explorers across a new frontier. Inside the Martian habitat, a small slice of Earth will be recreated. Living quarters will be compact, but functional, designed for both work and well-being. A common area will serve as a place for the crew to eat, relax, and connect with their families back home. The hum of air filters and water recyclers will be the constant soundtrack of life. Every drop of water, every breath of air, will be meticulously managed and recycled. This closed-loop system is a marvel of engineering, essential for long-term survival. But establishing a colony is about more than just technology and survival. It's about building a society. These first pioneers will be scientists, engineers, doctors, and technicians, working together with a shared purpose. They will lay the groundwork for a future where thousands and perhaps one day millions of people call Mars home. They are writing the first page of a new chapter in human history. The psychological toll will be immense. Isolation, confinement, and the constant awareness of being on a dangerous world will test the crew's mental fortitude. But their training, camaraderie, and the monumental importance of their mission will be their strength. They know they stand on the shoulders of giants and are paving the way for generations to come. From these humble beginnings, the colony will grow. New modules will be added. Tunnels might be dug underground for better radiation shielding, and local resources like Martian soil or regolith will be used to 3D print larger structures. What starts as a small outpost could evolve into a bustling town, and eventually a thriving city under a terraformed sky. The dream of becoming a multiplanetary species is within our grasp. It's a bold and audacious vision, one filled with unprecedented challenges. But the first humans on Mars will prove that with courage, innovation, and a collaborative spirit, nothing is impossible. They are not just exploring a new world. They are securing the future of our species. The age of interplanetary colonization is about to begin. Thank you for watching, and be sure to subscribe for our next chapter, where we look at the technologies that will take us beyond Mars and out into the solar system. Ever wondered what it would be like to look up at the night sky from another world? Let's take a journey to Mars and discover the celestial wonders that await. Forget everything you know about Earth's sky, because Mars offers a spectacle that is both alien and breathtakingly beautiful. Imagine standing on the rusty, red soil as the sun begins its descent. Here, the sunsets are not the fiery reds and oranges we're used to. Instead, the Martian sky paints a scene of ethereal blue. As the sun dips below the horizon, the fine dust particles in the thin atmosphere scatter the blue light forward, creating a glowing, sapphire-colored twilight that lingers around the setting sun. It's a serene, almost surreal experience, a soft blue glow against a darkening, butterscotch-colored sky. A truly otherworldly sunset that reminds you you're millions of miles from home. As darkness fully takes hold, the true celestial show begins. Mars has a much thinner atmosphere than Earth, meaning there's less gas and dust to obscure our view of the cosmos. The result? The stars don't twinkle. They shine with a steady, intense brilliance. The Milky Way isn't just a faint, milky band. It's a vibrant, detailed river of light, dense with countless stars stretching across the entire expanse of the sky. Nebulae and distant galaxies, often visible only through telescopes on Earth, would be discernible to the naked eye. It's a stargazer's absolute paradise, a window into the universe so clear it feels like you could almost reach out and touch the constellations. But the real headliners of the Martian night are its two moons, Phobos and Deimos. Unlike our single, stately moon, these are tiny, potato-shaped worlds, likely captured asteroids from long ago. Phobos, the larger and closer of the two, races across the sky. It's so close that it orbits Mars faster than the planet rotates. This means you could watch it rise in the west and set in the east, sometimes more than once in a single Martian night. It appears about 1/3 the size of our full moon, its cratered surface visible as it zips by. Then there's Deimos, the smaller and more distant moon. It moves much more slowly, taking over 2.5 days to cross the sky. It appears more like a bright star than a moon, a steady point of light leisurely making its journey. Imagine seeing these two celestial dancers performing their unique ballet against a backdrop of piercingly bright stars. One rushing, one dawdling. Sometimes they might even appear in the sky at the same time, a rare and spectacular conjunction. This double moon system creates a dynamic and ever-changing nightscape, completely different from the familiar, predictable cycle of our own moon. This celestial display has profound implications for future Martian explorers. Navigating by the stars would be easier than ever before. Astronomers would have an unparalleled platform for observing the universe, free from the atmospheric distortion and light pollution that plague Earth-based telescopes. The constant presence of Phobos and Deimos could even be used for timing and navigation, ancient methods adapted for a new world. But beyond the practical applications, living under a Martian sky would be a constant source of wonder and inspiration. It would reshape our connection to the cosmos. The blue sunsets, the unwavering stars, and the dance of two moons would become the new normal, a daily reminder of humanity's incredible journey into the solar system. It's a vision of the future, a sky that is waiting for us to look up and see it with our own eyes. From the serene blue twilight to the nightly celestial ballet, the Martian sky is a universe of beauty all its own. For millennia, we've gazed at the stars and wondered, are we alone? But what if the answer isn't out there in the distant cosmos, but hidden right here in our own solar system, in the silent, rusty dust of Mars? In 1976, NASA's Viking 1 orbiter was mapping the Martian surface when it captured an image that would ignite a firestorm of controversy. There, in a region called Cydonia, was a rock formation that looked uncannily like a human face. It was enormous, nearly 2 miles long, staring blankly up into space. Scientists at NASA dismissed it as a trick of light and shadow, a geological feature that just happened to resemble a face. But for many, this explanation wasn't enough. Could it be a monument? A message? The last remnant of a long-lost Martian civilization? The face on Mars became an icon of our search for extraterrestrial life. Independent researchers pored over the low-resolution images, claiming to see more than just a face. They pointed to nearby formations that they said looked like pyramids, a fortress, and even a city square. They argued that the geometric precision and arrangement of these structures were too perfect to be natural. It was, they claimed, an entire complex, a Martian city buried by the sands of time. This theory captured the public imagination. Books were written, documentaries were made, and a passionate community grew around the idea that NASA was either overlooking or deliberately hiding the greatest discovery in human history. The Cydonia region wasn't just a random patch of Martian desert. It was an archaeological site of cosmic proportions. Proponents developed elaborate narratives of a sophisticated Martian society that flourished millions of years ago, perhaps destroyed by a planetary catastrophe, leaving only these enigmatic ruins behind. Was this just wishful thinking? A classic case of pareidolia, our brain's tendency to see familiar patterns like faces and random shapes? Or was there something more to it? The debate raged for decades. The original Viking images were grainy, leaving plenty of room for interpretation. The shadows played a crucial role, carving out the features of a nose, mouth, and eyes. Skeptics argued that if you looked at it from a different angle, or with different lighting, the illusion would shatter. Believers countered that natural erosion couldn't possibly create such a symmetrical and complex structure. They demanded that NASA take another look. Finally, in the late 1990s and early 2000s, new missions with far more advanced cameras, like the Mars Global Surveyor and the Mars Reconnaissance Orbiter, did just that. They returned to Cydonia and captured stunningly high-resolution images of the infamous face, and what they revealed was a hill, a heavily eroded natural rock formation known as a mesa. From these new, crystal-clear vantage points, with the sun at a different angle, the face-like features vanished. The illusion was broken. The eyes and mouth were revealed to be nothing more than pits and craters. The pyramids, just ordinary Martian mountains. For the scientific community, the case was closed. The face on Mars was officially debunked, a textbook example of how our minds can play tricks on us. It joined the ranks of canals on Mars and other early astronomical misinterpretations. But for some, the story doesn't end there. They argue that the newer images may have been altered, or that the true structures are still hidden beneath layers of dust and debris. They believe the mystery of Cydonia is far from solved. So what is the legacy of the face on Mars? It wasn't an alien monument, but it became a monument of a different kind. It represents our profound, unyielding desire to find connection in the vast, cold emptiness of space. It's a symbol of the tension between scientific skepticism and the power of human imagination. It forced us to look closer, to build better cameras, to explore more deeply. In our quest to find an alien face, we ended up getting to know the face of Mars itself in breathtaking new detail. But the solar system is a vast place, and Mars is just one world. The debate over Cydonia was just one chapter in a much larger story. As we push further into the cosmos, we continue to find anomalies that challenge our understanding. Strange signals from distant stars, unexplained atmospheric phenomena on Venus, and peculiar geometric patterns on icy moons. One of the most intriguing is the mystery of Tabby's star, located nearly 1,500 light-years away. This star exhibits bizarre and dramatic dips in its brightness, unlike anything we've ever seen. Astronomers have proposed dozens of explanations, from a swarm of comets to the dust of a planetary collision. But one tantalizing, albeit highly speculative, hypothesis remains on the table: an alien megastructure. Could a vast swarm of solar collectors, a Dyson sphere in the making, be orbiting the star, built by an advanced civilization to harvest its energy? While most scientists favor a natural explanation, the data is so strange that the possibility of technology can't be completely ruled out. It forces us to ask, what would alien technology even look like? Would we even recognize it if we saw it? From a weathered rock on Mars to a flickering star in a distant galaxy, these mysteries remind us that the universe is far stranger and more wonderful than we can possibly imagine. They fuel our curiosity and drive us to explore. While science has provided a natural explanation for the face on Mars, it also showed us the importance of asking, what if? Because every great discovery in history began with a mystery, a question, and the courage to look for an answer. The search for life beyond Earth continues, and who knows what we'll find next. Maybe the next strange light or unexplained signal will be the one that changes everything. What does the future hold for Mars? It's a question that has captivated dreamers for centuries, but now it's a question for engineers, scientists, and pioneers. The next few decades will be a turning point, transforming Mars from a distant red dot into a new frontier for humanity. The challenges are immense, from creating breathable air to protecting against radiation and growing food in alien soil. But human ingenuity has always thrived on such challenges. Step by step, we are developing the technologies to make this dream a reality. The first human missions will be about survival and exploration. Astronauts will be our eyes and ears, conducting critical experiments and laying the groundwork for a permanent presence. They'll test life support systems, study Martian geology for water ice and valuable minerals, and learn to live and work in an environment that is utterly hostile to human life. These early outposts will be small, self-sufficient habitats, marvels of engineering designed to keep our pioneers safe while they unlock the secrets of our celestial neighbor. Every experiment, every soil sample, every discovery will bring us closer to a sustainable future on Mars. As we move toward the middle of the 21st century, say around 2050, the Martian landscape could look very different. Imagine sprawling, interconnected domes glowing softly under the thin Martian sky. Inside these biospheres, a new way of life is taking shape. Humans might walk freely, protected from the harsh environment outside. The air would be carefully manufactured and recycled, a precious commodity that sustains a bustling community. These aren't just scientific outposts anymore. They are the first towns on another world, complete with living quarters, research labs, recreational areas, and medical facilities. Life inside these domes will be a delicate balance between technology and nature. Advanced hydroponics and aeroponics systems will allow us to grow crops in vertical farms, with rows of leafy greens and vegetables flourishing under specialized LED lights. But the ultimate goal is to cultivate the Martian regolith itself. Scientists are already working on ways to detoxify the red soil and enrich it with nutrients, turning it from sterile dust into fertile ground. Picture this: a greenhouse on Mars, the red soil teeming with earthly crops, a testament to human persistence. Food won't just be about sustenance. It will be a connection to home, a taste of Earth billions of miles away. And with a permanent settlement comes a new generation. Children born on Mars, the first true Martians. For them, Earth will be a story, a beautiful blue marble in their sky. They will grow up in a lower gravity environment, which could mean they'll be taller and have different physical adaptations than their Earthbound ancestors. Their playground might be a supervised, pressurized rover bay or a virtual reality room that simulates Earth's forests and oceans. They will be the native inhabitants of this new world, inheriting a legacy of exploration and pushing the boundaries of what it means to be human. Communication between Mars and Earth will be a constant, vital link. It will be a lifeline for supplies, a conduit for knowledge, and an emotional bridge for families separated by the vastness of space. However, due to the planet's orbits, there will be a time delay of up to 22 minutes for any message. This isn't like a phone call. It's more like sending emails or video logs back and forth. Can you imagine sending a question to a loved one on Earth and having to wait up to 45 minutes for a reply? This communication lag will shape the culture of the Martian colony, fostering a unique sense of independence and self-reliance. But the journey isn't a one-way trip. As the colony becomes more established, rockets will launch from the Martian surface, carrying people and precious scientific data back to Earth. The technology to launch from Mars will be a huge milestone, likely involving the production of methane fuel from Martian resources like water ice and atmospheric carbon dioxide. These return journeys will solidify the interplanetary connection, creating a two-way highway between the worlds. The first explorers returning from Mars will be heroes, bringing with them not just rocks and data, but stories and experiences that will inspire generations to come. Looking further into the future, the ambition grows. The dream of transforming Mars into an Earth-like planet is the ultimate goal for many. This is a project on a millennial scale, involving slowly thickening the atmosphere, warming the planet, and eventually creating liquid water on the surface. It might start with releasing greenhouse gases stored in the Martian soil and polar caps. Over centuries, we might see the Martian sky turn from a pale pink to a deeper blue. We might see rivers flow again in the ancient dried-up channels. It's a monumental undertaking fraught with ethical and technological questions, but it represents the peak of human aspiration. The colonization of Mars will fundamentally change humanity. It will force us to become a multi-planetary species, safeguarding our existence against any single catastrophe on Earth. It will drive technological innovation in ways we can't even imagine yet, with breakthroughs in energy, recycling, medicine, and robotics that will benefit life back on our home planet. More than that, it will expand our perspective. When we look up at the night sky and know that members of our human family are living on that tiny red light, our sense of home, our sense of community, and our sense of possibility will be forever enlarged. The future of Mars is not just a science fiction movie plot. It is a tangible goal that we are actively working towards. It's a story of courage, of innovation, and of the unyielding human spirit to explore, to discover, and to build a future among the stars. The path ahead is long and difficult, but the first steps have already been taken. The red planet awaits not as an endpoint, but as the next great beginning in our human story. Thanks for watching, and if you're as excited about the future of space exploration as I am, make sure to like and subscribe for more.